In order to add and subtract mixed numbers, what I recommend doing is turning all of your mixed numbers into an improper fraction. So an improper fraction is whenever you have a single number on top and a single number at the bottom of the fraction. So this is improper as opposed to something that looks like this, which is a mixed number. So a mixed number has this whole number that's off to the side and then it has another fraction attached to it. So what I want to do is I want to turn this mixed number into a fraction that has one number on top and one number on bottom. I believe I've gone over this in a previous video, but in order to do that, it's fairly straightforward. What you do is you take your whole number that's off to the left of the fraction and you multiply it by the denominator. So in this case, we do 6 times 6. 6 times 6 gives us 36. And we're going to take this number and add it to whatever number is at the top of the fraction. In this case, we're adding it to 5. When we do this, we end up getting the number 41. So this entire fraction, this entire mixed number, ends up becoming 41 over whatever the original denominator was, which in this case is 6. So 6 and 5, 6 becomes 41 over 6. So now we're going to take this number and we're going to rewrite this original expression. We're going to rewrite 3 over 4 plus, but instead of using this mixed number, we use the new improper fraction that we wrote, which is 41 over 6. So now our goal is to focus on this expression and actually work it out. We need to add these two fractions together. And the way we do that is by getting a common denominator. So if we look at our denominators, we have a 4 and we have a 6. Multiples of 4 would include 4, 8, 12, 16. If we make a list of multiples of 6, we would have 6, 12, 18, 24. What number do they share? Well, they end up sharing the number 12. So ideally, what I want to do is turn both the 4 and the 6 into the number 12. If we take it one fraction at a time, how do I turn this 4 into the number 12? Well, I need to multiply it. What do I multiply it by? I multiply it by 3. So when we're changing these fractions around, what we do to the bottom of the fraction, we do to the top as well. So I'm multiplying the top by 3 because I multiply the bottom by 3. This fraction would then become a 12 in the denominator, and then we have a 3 times 3 in the numerator. We end up getting a 9. So we're done converting this fraction into a denominator that has a 12 at the bottom. Now we repeat the process for this 41 over 6. We need to turn the 6 into a 12. How do we do that? Well, you need to multiply the 6 by something, and that something would have to be a 2. What do we do to the bottom of the fraction? We do to the top, so I need to multiply 41 by 2 as well. 41 times 2 gives me 82, and 6 times 2 gives me 12. We still have this plus sign, so we just carry it down here. And this is our new expression. We have 9 over 12 plus 82 over 12. Now that they have the same denominators, we know that my answer is going to have a 12 in the denominator. Next, we need to go ahead and add these numerators together. So we're doing 9 plus 82. And 9 plus 82 gives me 91. So we get 91 over 12. At this point, if the answer asks us for an improper fraction, then this would be my answer, because we wouldn't be able to simplify it. The problem is, this question does want us to write it as a mixed number. So now we need to convert this improper fraction back into a mixed number. And the way to do that is by doing the division. I don't believe you're allowed to use a calculator for this section. So you can either set it up as a division problem, a long division problem like this, or you can just kind of think through it. And what I mean by that is we can figure out how many times 12 goes into 91 just by thinking through it. So 12 times a number like 5 would give us 60. 12 times 6 would give us 72. And 12 times 7 would give you 84. If we tried multiplying 12 times 8, that would give us 96, which goes past this 91. So we're going to go with the 7. 12 goes into 91 7 entire times. So what is 12 times 7? Well, if we go back to what I was saying, 12 times 7, if we work it out the long way, 7 times 2 gives us 14. 7 times 1 gives us 7, plus the other one will give us an 84. So 12 times 7 gives us 84, but my goal is to reach this original 91 value that we had. So what's the difference between these two numbers? In other words, what is 91 minus 84? Well, if we're at 84, we would need to count 7 more times to reach the number 91. So we're going to get a fraction of 7 over 12. And again, what we're really doing is we're doing 91 minus that 84. If we do the subtraction, if we try subtracting 1 minus 4, you cannot do that. So you got to borrow 1's place from the 9, and the 9 becomes an 8. And the 1 becomes really an 11. 11 minus 4 gives us a 7. So that's where I got this remainder up here. So that last step was just turning this improper fraction into a mixed number, and this mixed number is my final answer. So for this problem, we have two mixed numbers. Just like the previous question, I want to go ahead and turn both of these mixed numbers into improper fractions. So we're going to do it one step at a time. First, we're going to focus on 6 2/3. To turn it into an improper fraction, we take the whole number and we multiply it by the denominator. 6 times 3 gives us 18. Now we need to add the numerator to that value. So 18 plus 2 gives me 20. So this expression is really 20 over, and my original denominator is a 3, so it stays as a 3. So we just turn this mixed number into an improper fraction. Now we're going to repeat this process with the 7 3/4. So we take the 7, we multiply it by 4. 7 times 4 gives me 28, and then we add 3 to it. 28 plus 3 gives me 31. So this fraction becomes 31 over, my original denominator was a 4, so that's going to be a 4 at the bottom. These two numbers are being added, so we go ahead and copy the plus sign over. And now we need to focus on this set of fractions. We need to add them together. In order to add them together, they need to have the same denominators. So we need to find a common multiple of 3 and 4. If we count by 3's, we would count 3, 6, 9, 12, 15. And if I count by 4's, we would get 4, 8, 12, 16, and so on. What number do they share? Well, they end up sharing a 12. So we need to turn both of these denominators into the denominator of 12. For this first fraction, we have a 3 at the bottom. So how do I turn a 3 into a 12? Well, I need to multiply it by, in this case, 4. 3 times 4 would give me 12. What I do to the denominator, I do to the numerator, so I need to multiply the top by 4 as well. 20 times 4 ends up giving me 80, and 3 times 4 gives me 12. So that first fraction, I'm actually just going to write it off to the side so it looks a little cleaner. This first fraction of 20 over 3 became 80 over 12. Now we repeat the process for the second fraction. We're trying to get the denominator to also be a 12. So what do I multiply 4 by to make it into a 12? Well, I need to multiply it by 3. What I do to the denominator, I do to the numerator. So we have 31 times 3 in the numerator. What is 31 times 3? That would be 93. So we end up getting a 93 for the numerator of this fraction, and then the denominator, 4 times 3 becomes 12. These two fractions are still being added together, so we copy down that plus sign and we continue with the problem. At this point, we've successfully turned this mixed number into an improper fraction, and we did the same thing for the second one. We turned that 7 3/4 into 93 over 12. Now that the fractions have the same denominators, we can go ahead and add the numerators together. So 80 plus 93. That gives me 173, and we have the denominator of 12. If the problem was asking for an improper fraction, this would be my answer. The problem is it's asking us for a mixed number. The way to do that is by going ahead and doing the division. This fraction is the same as saying 173 divided by 12. In this case, because the 173 is somewhat of a big number, I'm going to go ahead and divide these two values using long division. So how many times does 12 go into 17? Well, the 12 goes into 17 completely one time. So 12 times 1 is 12, and we subtract that from 17. We get a 5 as that remainder. Now we bring down the 3 and we repeat the process. How many times does 12 go into 53? Well, it goes into 53 4 times. What is 12 times 4? That's 48. So we subtract 48 from 53 and we're left with a remainder of, well, you can't do 3 minus 8, so you need to borrow a 1 from the 5. The 5 will become a 4, and this will become a 13. 13 minus 8 gives me a 5. So we have a remainder of 5. That means that for our final answer, my mixed number is 14, and my remainder of 5 out of the original denominator of 12. So this would be my final answer for the problem. So again, what we did is we took 173 and we divided it by 12. 12 goes into 173 14 entire times. And it leaves us with a remainder of 5. So that's where I got this 5 from. This denominator always stays the same when we're converting from improper fraction to a mixed number. To subtract mixed numbers, I would approach it the same as adding mixed numbers, which means I want to turn both of these mixed numbers into an improper fraction. Now for these next two problems, I'm going to rush my explanation just a little bit because I don't want to repeat every single thing that I went over in the first two problems. So for this first fraction, to turn it into an improper fraction, we multiply the whole number 4, by the denominator 4. 4 times 4 gives me 16, plus 3 gives me 19. Because it's a fraction, we need to keep this denominator of 4. Now we need to do the same thing for 1 and 1/7. So we take 1 and we multiply it by 7. 1 times 7 gives us 7. Then we add it to 1, and that would give me an 8. So 8 out of that original denominator, which is a 7. These two numbers are being subtracted, so we go ahead and copy down the subtraction sign. And now my expression looks like this, which isn't the answer, but it's the next expression that we need to work with. So in order to add or subtract fractions, we need to make sure that the denominators are the same. That means we need to find a common multiple between 4 and 7. If we count by 4s, we have 4, 8, 12, 16, 20, 24, 28. And if we count by 7s, we would count 7, 14, 21, 28, and so on. What number do both of these values share? What multiple do they share? Well, they end up sharing this 28. So that's what we need to turn those denominators into. We need to turn the 4 into a 28, and we need to turn the 7 into a 28. So how do we turn the 4 into a 28? Well, we need to multiply it by something. What do we multiply it by? We need to multiply it by 7. What I do to the denominator, I do to the numerator as well. So these numbers are quite big. 19 times 7. If we need to, we can work it out to the side. 19 times 7. 9 times 7 is 63. 7 times 1 is 7, plus 6 is 13. So we end up getting 133 over 4 times 7 was 28. So we're done with our first fraction. We convert it into an improper fraction, and we change it so that the denominator is a 28. Now we do the same thing with the second fraction. We need to turn that 7 into a 28. So what do we multiply in 7 by? Well, we multiply by 4. And what I do to the bottom, I do to the top. This leaves me with the fraction of 8 times 4, which is 32, over 7 times 4, which is 28. And for this problem, we're subtracting the fraction, so we put a subtraction sign down. Now that the denominators are exactly the same, we just need to subtract the numerators. So 133 minus 32. If we do that correctly, we end up getting 101. So we have 101 over 28. So at this point, we kind of have our answer. The problem is this is an improper fraction and not a mixed number. So now we need to convert it back into a mixed number. That means we have to go ahead and take 101 and divide it by 28. So we got to figure out how many times 28 goes into 101. Now for this problem, setting it up this way doesn't necessarily make it easier for us. We still got to figure out how many times 28 goes into 101. So instead of trying to divide it this way, what if we just counted by 28? 28 plus 28 would give us 56. If we add another 28 to this, we end up with 84. And if we add 28 more to this, we end up getting 112, which goes past the 101. So we're not going to include that. That means that 28 goes into 101 3 times. So it goes into it 3 times. But because we haven't reached 101, we're left with a pretty large remainder. So the last thing we would need to do is take 101 and subtract that 84 from it. If we try subtracting them, you can't do 1 minus 4, so you got to borrow 1's place from this 1 to turn it into a 0, and the 0 turns into a 10. But since we're trying to turn this 1 into an 11, we need to borrow from the 10 and turn that into a 9. And now the 1 becomes an 11. So 11 minus 4 gives me a 7, and 9 minus 8 gives me a 1. This leaves us with a remainder of 17. So for our mixed number, we know that 28 goes into 101 3 entire times, but we're left with a remainder of 17 out of those 28. So our final answer is 3 and 17 over 28. For this last problem, I recommend that we approach it the same way as the others. First, we turn the mixed number into an improper fraction. If we do it for the first fraction, 7 times 4 gives us 28, plus 1 gives me 29 over 4. For the second fraction, we hit 4 times 10, which is 40, plus 9 is 49 over 10. And we're subtracting both of these values. Because we're subtracting numbers, we need to make sure that the denominators are the same. So what's a common multiple between 4 and 10? Well, multiples of 4 would include 4, 8, 12, 16, 20, and so on. And multiples of 10 would include 10, 20, 30, 40, etc. What number do they share? Well, they share a 20. So that's the least common denominator that we want to get. We want to turn the 4 into a 20, and we do that by multiplying it by 5. So we multiply the top by 5 as well. So now we need to multiply 29 times 5 and see what that gives us. 9 times 5 is 45. 5 times 2 is 10, plus 4 is 14. So we end up with 145 over whatever 4 times 5 is, which is 20. So this is what we get when we convert this fraction into a fraction that has a 20 at the bottom. Now we repeat the process for 49 over 10. How do we turn the 10 into a 20? We multiply it by 2. So we multiply the top by 2 as well. 49 times 2 gives me 98 over 20. And these two fractions are being subtracted. So now that the denominators are the same, we can go ahead and do the subtraction. 145 minus 98. If we subtract them, 5 minus 8 we cannot do, so we take a 1's place from the 4. Now we have 15 minus 8, which is 7. And we do 3 minus 9, which we cannot do, so we borrow 1's place from the next value. The 1 becomes a 0, and this 3 becomes a 13. 13 minus 9 gives me a 4. So we're left with 47 over 20. So this is our improper answer. To turn it into a mixed number, we have to do the division. So you can either set it up the way we did some of the other ones, which is take 20 and divide it into 47, or you can just think through it. How many times does 20 go completely into 47? Well, that would be 2, because 20 times 2 would give us 40. And our remainder would be a 7 out of the original 20. So my answer ends up being 2 and 7 over 20. If you did it this way over here with the division, 20 goes into 47 twice. So 20 times 2 gives you 40. And if you subtract them, you end up with a remainder of 7, which is why my fraction had this 7 in the numerator. So I hope this helped. This video was a bit longer than I would have liked, but these problems can be a bit involved. There is another way of solving these problems, but it takes a bit more thinking, and as much as I would like to go over it, I do feel like this method that I'm using now of turning these mixed numbers into improper fractions, I feel like in the long run this will help you more than the other method of subtracting them, as the other method can get a bit confusing, and there's some details that I just rather not go into it if I don't need to. Anyways, hope this helped. Good luck with the rest of the assignment.